Children, although we are the witness of world's strictest lockdown, even though the toll of COVID positive reaches around 27k in the nation, so again and again we all observe do gaz duri hai zaruri, because there is no other remedy than social distancing. So children, in my last video lecture you already have seen that how the metals react with air, and some reactive metals react even very badly with the air and they get corroded either, or they burn also in the air. But now after the reaction of metal with air is over, and I have little much given you idea about the reaction of non-metals also with the air, where they are very restricted non-metals like carbon, phosphorus, sulfur, etc., which react with non-metals. I am now today is ready to give you the knowledge about the reaction of metals with water, because water is a very neutral substance. Then the question, because in the air oxygen is very reactive, so the it gives us an imagination that since oxygen is actually very reactive, it can combine chemically with the metals or non-metals. But since water is called a totally neutral substance, so will it be possible that the metals and non-metals react with water chemically? Reaction of metals with water actually depends upon that what metal we have taken and at what temperature water has been taken. So both plays very important role, and then if the metal is reactive in nature and the water is also at the right temperature for that metal, because the different metals react with water at different temperature. So if we have taken the water at adequate temperature, means at the right temperature for the given metal, then it will react vigorously with water and it will produce metallic hydroxide, which is actually nothing but a base. Metallic hydroxides are what? Base. And it will produce abundant of hydrogen gas. So actually we will slowly see that how the different metals react with water. So the metals which are very reactive in nature, we start with that only, that is your sodium and potassium. So sodium and potassium and calcium also. But there will be little difference between the reaction of sodium, potassium and calcium with water. They all are highly reactive, but one by one I will make it clear to you that how they are little much different from one another. Children, I have opted an activity to make you clear that how the potassium and sodium react with water. Water which is very cold in temperature, means water will be around chilled water has been taken in the beaker, and the piece of sodium and potassium is taken out from its jar, because they are always stored in kerosene oil, because they are very highly reactive from the with the air also. So they are stored always dipped inside the kerosene oil. When we take out a very small piece of sodium and potassium, and one by one in two beakers we keep very chilled water, just ice melted water you can say, and we, as soon as we put the piece of potassium with the help of tongue over the water, it burns vigorously with a pink flame and burns at the top surface of the water only, and then it converts into its ash and sinks down into the water. ये पहले तो जल जाता है पानी के सतह पे, और फिर ये जलकर उसकी राख में बदल जाता है, और तब ये पानी में घुल जाता है. As soon as it dissolves in the water, it produces a very strong alkali, that is your potassium hydroxide, and very tiny bubbles of hydrogen gas will be seen throughout the bulk of the water, and these are nothing but the very hot gases that brings the chilled water to the boiling temperature. The water starts boiling in this reaction, so it is such an exothermic reaction. It produces lots of heat because of the production of a highly inflammable and hot gas, that is your hydrogen gas. So what happens first? Potassium burns, then it sinks, and then it brings the water to boil, and the very tiny hydrogen gas is clearly seen everywhere produced in the beaker. Whereas in the case of sodium, as soon as we put the sodium in the water, sodium sinks down in the water immediately and brings the water to boil, and then again it is pulled by the hydrogen gas. Water is boiling. Why? Because the hydrogen gas has been produced in an enormous amount, and then the hydrogen gas pulls the piece of sodium to the surface of the water, and then sodium comes in the contact of air, and then it burns with blue flame. So this is the difference between the little much difference between the reaction of sodium and potassium with water. Sodium burns at the after it dissolves in the water and comes up, whereas potassium burns at the surface only and then it sinks. But they both produce very strong alkali. These are the combination of strongest alkali, which is together called caustic soda and potash. This is the common name, but the chemical name is sodium hydroxide and potassium hydroxide. Similarly, calcium also reacts with water vigorously, and that's true with the chilled water, and it produces lots of hydrogen gas, brings the water to boil, but it does not bond like sodium and potassium. This is the difference, and it produces the a little weaker alkali than sodium and hydroxide and potassium hydroxide. That is your calcium hydroxide, commonly known as lime water. This is the same thing which is used in the whitewashing of our houses. Slacked lime or lime water. So just now I tried to explain the reaction of those metals which are actually very reactive in nature, and how do they react with water. They react vigorously even with the cold water also. Now I am moving towards those metals which are moderately reactive, means their reactivity is neither very high nor very low. They are less reactive than those metals which are sodium, potassium and calcium. This is in this series the first will be taken as magnesium. Magnesium is also reactive metal only, but its reactivity is little lesser than those previously taken metals. Magnesium does not react with the cold water. Neither it reacts with the water which is kept at the room temperature unless we don't bring the water to its boiling temperature, means when the water will start boiling, and then if we keep the magnesium inside the boiling water, then the boiling water will react with the magnesium and it will make the magnesium dissolve in the water and produce a very milky color solution, that is your milk of magnesia, a weak base, that is the same base which is used in the antacid tablets etc. and toothpaste etc. to cure the acidity. So this milk of magnesia is a suspension like substance, a little less soluble. That's why it makes the water milky and hydrogen gas is produced. Now the aluminium, whose reactivity is even also lesser than your magnesium, how does it react with water? When you take the boiling water and you try to react with the metal like aluminium with it, it will not react unless the water has not converted into steam, the highly hot and gaseous state of water that is produced at the 100 degrees Celsius only. So steam combines with the water. What happens actually in the industries, that is called your metallurgical industry, steam furnaces. There is a you can say a structure like a box or big tank in which the steam is filled by the boiling water, and in that aluminium sheets are inserted or kept. So these steam start combining with the aluminium, and instead of producing hydroxide of the metal, because you have seen that in every previous reaction a metallic hydroxide has been produced, which is a base, oxide of the metal is produced. Aluminium oxide will be forming over the aluminium sheets, and that is also called commonly white oxide. This white oxide is actually the protective layer of the aluminium, which protects it from the corrosion or getting rusted. So whenever aluminium is sold in the market, before coating it with the protecting layer of white oxide with the help of steam, it is not for the sale, and hydrogen gas is produced. So white oxide is what? It is a protective layer over the aluminium sheets. That's why aluminium does not get rusted, only because of the formation of aluminium oxide over the top surface of the aluminium sheets. Similarly, exactly in the similar way, iron and zinc also produce white oxide and red oxide and yellow oxide when they combine with steam. They both also do not combine either with normal water or boiling water, but they combine only with the steam. And this red oxide and yellow oxide is also has the same function to protect the iron and zinc from getting corroded or rusted. Red oxide is coated over the iron rods etc., सरिया वगैरह जिसको आप कहते हैं. So and then it does not get rusted and used in the construction business. Now what happens when the least reactive metal or their reactivity is as equal as negligible? These are called also noble metals. These noble metals are copper, silver, gold, platinum, etc. So when we take copper and we keep it inside either hot water or cold water or chilled water or steam, nothing will happen. That is why you have seen that copper pots are usually everywhere commonly used to store water in it, and it makes the water better in its quality instead of reacting with water. So noble metals do not react with water, so there is no reaction in the product. So guys, after giving sufficient time on the reaction of metals with water, let us move towards the another topic which also comes under the chemical properties of the metals and non-metal, and this is your reaction of metals with acids. Acids are highly reactive substance. It's very commonly known that acids react vigorously with the substances it comes in contact. Acids similarly are very reactive towards the metals also, but that depends upon that what acid has been taken, what is the concentration of acid, means if acid is diluted with water or acid is highly concentrated, and what metal you have taken. So because the reactive metals react so vigorously with acid that we can't carry out the reaction in the lab, like in the case of sodium and potassium, it's not possible to carry the reaction of sodium and potassium with even dilute acid. They are so reactive. But we can do this experiment with the moderately reactive metals, which are your zinc, iron, aluminium, etc. So acids react vigorously even with the dilute acid and at the normal temperature, and they produce salt of that metal, and hydrogen gas is also produced. So this hydrogen gas actually is again conformed. How do we know that hydrogen gas is produced? It is a very simple test, that we bring a burning matchstick or splinter near the test tube in which we have performed the experiment, and hydrogen bubbles are coming out from the test tube. It will start burning with the popping sound. So this is your confirmation test that the hydrogen burns with pop sound, and then we understand that the gas produced is your hydrogen gas. What we do, that we take little much dilute acid in the test tube and we add a piece of zinc, and then we watch what happens. We only have to see that what is going on inside the test tube. You will see that soon very tiny bubbles of the hydrogen is produced in the acidic solution, and then the transparent mixture is formed, and that is your zinc chloride, due to the formation of zinc chloride, which is a salt. So and aluminium is also reacts with the acid to form aluminium chloride, zinc chloride, aluminium chloride. Here calcium, I have given the reaction of calcium with dilute sulfuric acid, calcium sulfate is formed, and everywhere uniformly hydrogen gas will surely form. Now, noble metals like copper, silver, etc. do not react with dilute acid because their reactivity is very less, or you can say that reactivity is under a special condition only. So, they do not react with dilute acid. But when we take a very concentrated acid, and that also at a higher temperature, means we heat the acid and then we try to react it with the copper metal, then it will react, but it will not produce hydrogen gas. This answer I will tell you after I take the displacement reaction, that why hydrogen gas is not produced when the copper reacts with acid, that is your concentrated acid. A salt of copper will be formed, that is your blue vitriol, also we call it copper sulfate, and water will be produced instead of hydrogen gas. Why? Because the concentrated acids are very dehydrating substance. It absorbs moisture of the air and produces water. This I will take in another class, that is your displacement reaction. Now I am telling you that why I have not taken today the reaction of non-metals with water and acid. So simply I am saying that the non-metals do not react, neither they react with water nor acids.